Alright guys, we're going to continue on with section 12-1, tangents and circles. And what we're going to do is we're going to use the Pythagorean theorem on this one. So we got to go back to our Pythagorean theorem, a squared plus b squared equals c squared. Remember, a and b are your legs, the two sides that form the right angle. And then c is the side, the hypotenuse, that's opposite the right angle, okay? And what we're going to be doing in the two examples I'm going to do with you, we're going to be finding a radius, and I think you do have one that is like this on the quizzes. The other problems on your quizzes, you're still using Pythagorean theorem, but you're not finding a radius, you're just finding one of the other missing sides. So it's a pretty easy, really it's pretty easy. In fact, this problem right here, which I think you only have one on the quizzes, is the hardest. The other four or five, I can't remember how many I gave you, but they'll be the easier ones. All right, so yesterday we talked about tangents. Remember, a tangent is a line that's on the outside of the circle that only touches it one time, and it makes a right angle where it does touch. And that's what's allowing us to be able to use Pythagorean theorem on these problems. So in my picture, I've got my circle over here, my triangle that's drawn using that tangent. Now these are the radii for a plural, but radius. And right now, all I know about the radius is that it equals x. So I gotta find the radius. I know that this distance right here is 12 from A to B. This distance, I don't have a letter right there, but from here to here is 8. From here to here is x. So when I do the whole thing, I gotta kind of think outside the box to get that whole measurement. We'll talk about that in a minute. All right, so all we know is that the radius is equal to x. We know that we can use Pythagorean theorem because of what, that right triangle. And in my triangle, AC, which is this one, is opposite the right angle, so that means that AC is the hypotenuse. All right, so we already talked about how AB equals 12, BC equals x, and then to get this whole segment length, I have to put x and 8 together. So it's going to be x plus 8 for that whole segment length. And because that hypotenuse is x plus 8, that's what makes this problem a little more difficult than the other ones that you're going to see on the quizzes. All right, so I just plug those numbers into my Pythagorean theorem, okay? Normally we just do a squared, b squared, and c squared, but I'm using the side lengths on this one. So ab squared, which is going to be 12 squared, bc squared, which is going to be x squared, and then ac squared, which is going to be x plus 8, the whole thing squared, okay? All right, so this side's pretty easy. 12 times 12 is 144. X squared is just x squared. This is the side that causes kind of a little bit of problem, okay? So x plus 8 squared means literally that I have two of them, x plus 8 times x plus 8. So I have to go do a little more algebra on this problem. Go back to, you guys remember doing FOIL, first, outside, inside, last, or it's really just the distributive property, however you want to think of it. But I have to take, first I need to take x times x, that's where that came from, and then x times 8. And then I want to do 8 times x and 8 times 8. And then I need to clean it up a little bit. So x times x turns into x squared. X times 8 is 8x. 8 times x is also 8x. 8 times 8 is 64. Combine like terms. 8x and 8x is 16x. And then I can take that expression and put it back over here. So x plus 8 squared turns into x squared plus 16x plus 64. All right, now if you notice at this point, I have an x squared on the left-hand side and an x squared on the right-hand side. So those two are just going to cancel out. So I'm left with this because the x squareds disappear. 144 equals 16x plus 64. So I do my normal steps and solve for x. I'm going to subtract 64 from both sides. 80 equals 16x, and then divide by 16. And x equals 5. which is the radius. All right, I'm going to do one more that's just like this one because, like I said, this problem right here is going to be the harder of the problems on your quizzes. So I want to make sure you understand it. All right, so similar setup. My radius is x, AB is 10, BC is x, and then AC, I didn't write it out like I did in the other one, but AC is going to be x plus 6. And AC is still going to be the hypotenuse because it's opposite the right angle. So when I plug it in, I'm going to get 10 squared plus x squared equals x plus 6, the whole thing squared. 10 squared is 100. X squared is just x squared. And then over here, we're going to do the same thing. We're going to write this as two different x plus 6's inside parentheses. And again, you can either do the first outside, inside, last, or the distributive property. So I'm taking x times x, x times 6, 6 times x, 6 times 6. This is going to give me x squared, 6x, 6x, 36. Combine like terms, x squared plus 12x plus 36. So when I square x plus 6, parentheses squared like that, it just turns into x squared plus 12x plus 36. Now the same thing's happening on this one. I have x squared on the left and an x squared on the right, so those are going to cancel out. And I'm just left with 100 equals 12x plus 36. So I'm going to subtract 36 from both sides and get 64, and then divide both sides by 12. Now this one does come out to be a decimal. I just rounded it to 5.3. So 5.3 is equal to x, which is my radius. So like I said, you have like 5 or 6 problems, or maybe just 4, I can't remember. One of them is like this. The other 3, you're still using Pythagorean theorem, but you're only finding like one of the sides. You're not finding the radius, okay? All right, make sure you do both of the quizzes, the attendance and the assignment, and then we'll see you tomorrow.